Hello and welcome to yet another episode of Oh My JavaScript. And in this series, let's take a deep dive into all the major features, functionalities and syntax changes ES6 has to offer. These topics are prerequisite before jumping into TypeScript or any other modern single-page application frameworks like Angular, React or Vue. So without further ado, let's jump straight into the content. In 2009, ES5 was standardized, and as of now, that's the standard implementation of JavaScript across browsers, which means browsers are still running behind. We write modern JavaScript and use Babel or other ES6 transpilers to compile them into something that's compatible across older browsers. As I told, ES6 or ES 2015 or ECMAScript 2015 is the upgraded version of JavaScript. And in this release, there was new features and functionalities, syntax changes, addressing language-related quirks like lexical scope, adding a new primitive, and making it more developer and beginner-friendly. If we add TypeScript along with ES6, that becomes even more powerful. Jumping into the list of functionalities that ES6 has to offer, let's start with let and const. Let and const are alternatives to var. We used to declare a variable using var, but instead of var, we could replace them with either let or const. Both of them bring something called a block scope. In ES5, the older JavaScript, what we used to have is global scope and function scope. And with let and const, we have one more scope called block scope, where a variable has life in between a curly brace or a block in JavaScript. Let's declare a variable called language and define a value called JavaScript to it. Let's have an if block, and within the if block, let's do the same thing. Let's declare the same variable, but this time let's define another value to it called Java instead of JavaScript. Let's console both the values and see what it prints. It prints Java on both console because by line 4, it essentially overwrote the same variable since we are using var, which has got global scope. And so by line 5, all we have is the new value called Java. So the same value would be printed on line 5 as well as line 7. I said we could replace var with let. So once we do that and save, now we could see that line 5 has printed Java, whereas line 7 has printed JavaScript, because with let, what we are creating is a block scope. So within this block, whatever we have declared and defined lies within the same block. So we have the separation of global scope as well as block scope. Whatever outside the if block is on the global scope, and whatever within the block is block. So we have that separation between the global scope and block scope, even though we have used the same variable. If I'm replacing the let with const, essentially nothing is going to change here because the functionality is still intact. The difference is that with const, you are forced to have the definitions along with the declarations. If I try to do it separately, it says you cannot do that because, so I'm saying language equal to JavaScript. So if I try to do this, the IDE itself give me a warning saying const declarations must be initialized. So the moment I'm using const, I'm forced to supply the value along with the variable. So I need to revert back to the syntax where we have the declarations and definitions together. When we are using const, usually we provide capital letters. So things like pi is equal to 3.14 or const app underscore URL is equal to www.something.com. So whenever we are using const, we indirectly use the capital letter to help the developer know that yes, this is a constant whose values is not going to change. There is a difference when we are using the primitive types and reference types though. If we are using a reference type, that is an object or an array, say const address, or let's go ahead with the caps, equal to now instead of a number or a string, what we have here is an object. So I could still go ahead and do address dot pin is equal to say a different value, and I could go ahead and print the value of address. It will not throw an error because objects are reference types, and this property, this address property is pointing to the same memory location, and all we are doing is just updating the property of an object, and the object itself is not changed and intact. So const allows us to change the properties of an object. But the problem is that if I try to do is equal to a different one, and now if we save, the compiler threw an error saying assignment to a constant variable, because we initially told that address is a constant and that's not supposed to change, and on line 6 we are essentially trying to override the same property with a different object. So this is not possible, but we could go ahead and update a particular property within an object or an array. So that's the difference between var, let and const. The next feature in list is template literals. Template literals is relatively a simple feature. Now this makes working with strings pretty simple. Let's declare a function called function print details, and this function accepts a few parameters called name, job and city, and within the function I put a variable called message, and I have attached a set of strings saying hey plus whatever the name we pass is working as whatever the job we pass at whatever the city we pass. So we essentially constructed a string by attaching few variables within. So the problem with this approach is that we need to explicitly put spaces, make sure that there are plus to concatenate string with a variable. This becomes cumbersome as the length of the string increases and we might miss on a single quote or a plus. So we could console the value and we could invoke the function with a set of parameters and see that we have the output as we expect. Hey, John is working as a developer at Hamilton. So this can be made better using template literals. With template literals, I can construct the same function, accept the same parameters, but instead of having the string plus concatenating with a variable, with a plus, with again another string, then a plus, this kind of an approach, we could go ahead with something called template literals. So we have a variable called message, but instead of going this way, there is something called backticks, which is at the bottom of the escape key of the keyboard. So backticks plus a combination of dollar along with opening closing parenthesis. So this essentially evaluates an expression. So we could write the string as is and then sprinkle this dollar plus opening closing to mark an expression that needs to be evaluated. So here we could say console.log message. I can invoke the function with the parameters, and if we check the output, both are identical, but the second approach seems to be much more concise. So that is template literals for you. The next feature in list is arrow functions. Arrow functions offer changes in terms of syntax as well as functionalities. with arrow functions, it made it much easier to write the functions as well as address the lexical this issue we had with functions. Let's have a function called function add of a comma b. So let's have a function called add which accepts a and b as the parameters, and within the function let's say return a plus b. So pretty simple function. Let's assign the function's invocation to a variable called sum, and if I console.log, we have the sum. Nothing new here. So this function can be written using the new arrow syntax like this. So const, so instead of the same name I'm giving add numbers without the function keyword, and all I'm saying is a comma b points to the braces and return a plus b. So this and this is essentially the same. The syntax slightly differs, but both are functions. So the moment the compiler sees this arrow function, it's smart enough to understand that, okay, this refers to a function parameter. So we could say const mysum equal to invoke the function, pass in the parameters 3, 4, console the value, and this should be the same. So approach 1 and approach 2 yielded the same value. One, the traditional approach, and second, the arrow function approach. Now this can be written in multiple ways. If we have more than one parameters, we need the opening closing brackets, and if there is only one single statement to return, we can omit the braces, the whole body, and we could say a comma b returns a plus b. So if we save, this should still give us the same value. If there is only one parameter, then the brackets are optional. So if we say const square equal to a points to a into a, and I'm saying square of 2, this returns 4. So if I pass a different value 4, it should give us 16. So this is syntax related change, but more than the syntax related change, arrow functions provided a solution for addressing the lexical this issue we had in ES5, especially with functions. So to see that, let's have an object called team. So an object can have properties as well as methods. So let's have some properties. So let's have a property called members, which is an array saying Hulk and Captain America. Let's have another property called team name. So obviously Hulk and Captain America is part of Team Avengers. Let's have a method called team summary. So the team summary points to a function, which is a method, and this function returns something. So here I'm saying this dot members, which is the members property here, dot map. Map is an ES6 function which helps us iterate over collections and transform them if needed. So within the map, I'm saying let's have a function. So iterate over members, and for each instance return a string. So here I'm saying, so member is a part of this dot team name. So essentially what I'm hoping to see is this dot members is an array. So please iterate over the array, and for each instance, so for each instance, I need to return Hulk, which is this one, is a part of this dot team name, points to Avengers. So I am hoping to see Hulk is a part of Avengers, Captain America is a part of Avengers. So let's invoke the method property and see what we get as the output. So if I console, I could see that Hulk is a part of undefined, Captain America is part of undefined. Why? I was expecting to see team name to be Avengers rather than undefined, but we don't have the team name because here within the map, what we are using is a function. So every time we invoke a function, it creates a function context. So within this context, there is nothing called team name. And that's why it says, I cannot find a property called team name. So I revert back to the default value of undefined. So to fix this issue, if we use an arrow function instead of a traditional function, so let's replace the function, and to make an arrow function, let's put the arrows. So if we save this, now we have Hulk is a part of Avengers, Captain America is a part of Avengers, because with arrow functions, the context inside and outside are the same. The lexical scope doesn't change. So this is one good thing with using arrow functions, because we don't need to explicitly bind the value of this within the function, because we know whatever the value of this inside will be the same as what we have outside. To see the ES5 solution, let's take a step back so that we revert back to the point where we were having undefined. And to the function, if we add dot bind of this, now we'd be able to get this dot team name right, because we have set this context to where it belonged. So this used to be the previous way of doing the binding for this context, but with the arrow functions, we can save ourselves from using this convoluted method. So that is arrow functions, syntax changes, features and functionality for you. The next in line is object literals. Object literals makes it easy to create objects by omitting the value if key and value are both the same. To see it in action, let's have two variables, so pin and a city. Let's have an object. So object is a collection of key value pairs, right? So in this address object, let's have a key called pin. Its value is our variable called pin. And let's have one more property called city, whose value is our variable city. And if we console the object, we get pin 1234 city Brampton. So we have an object with these two properties. So if this is the case where the key and the value are same, we could conveniently omit one and let JavaScript figure out the fact that both are same. So JavaScript behind the scenes will add the key colon value format for us. So that is object literals for you. The next feature is default arguments. Functions can now have default arguments, so that if we omit passing the parameters to the function, the default value is taken. Let's have a function called function print details that accepts name and is admin as a parameter, and let's console both the parameters. Let's invoke the function and pass in the arguments. So since we have passed in the arguments, we have Ben and false getting printed. Instead, if we don't pass the arguments and save it, both becomes undefined. So to avoid this, we can have a fallback value for name as well as isAdmin. So in this case, even if we haven't passed any arguments, it will fall back to the default value of user and false. So that is default arguments in ES6. The next feature is destructuring. So we can have objects and arrays destructured. The word destructuring sounds a bit cryptic, but the functionality behind the scenes is pretty simple. all it does is it pulls out properties from arrays and objects and assigns them into variables all by themselves. So let's have an object called address, which has got two properties, pin and city. Previously, to have pin and city pulled out, we needed to use const pin equal to address.pin and const city is equal to address.city. But with destructuring, we could do these two steps in one single line. We could write something like this: const, and instead of having two variables to hold these two properties, pin and city, I can write const, the curly braces on the left side of the equals, and the object from which we need to pull out the properties from. So this one single line says, hey, from the address object, pull out pin and city, create a variable called pin and city, and assign the value of pin and city towards those variables. So a lot is happening behind the scenes. So if we console the value, I'll comment these two lines and console pin and city, it should still give us 1, 2, 3, 4 and Milton. So obviously this one single line does the purpose of these two lines. So that is object destructuring. Array destructuring is something similar. Let's create a small array. So I'm saying const colors is equal to an array which holds some strings. I'm saying let this be a string array holding red, blue and green. And similar to object destructuring, we can do array destructuring. So I'm saying from the colors const, so instead of the curly braces in the previous example, let's have square brackets, and within the square brackets I can put whatever I want. So this is basically index based because this is an array. So I'm saying from the colors array, so whatever at index 0, please assign that into the variable called R. Whatever be in index 1, please assign it to a variable called B. And whatever be at index 0, 1, 2, please assign that into the variable called G. So if I console.log R, B and G, we'll get the same value. So this need not be R, B or G. I can do first, second, third, and I can console the value first, second and third. This should still give us red, blue and green because these are just placeholders for the index, because this is an array and array is index based. So if I wanted to omit something, I can still go ahead and do something like this so that we only have first and third. So we omit the first index and get the 0th and the second index. So that is array destructuring. The next functionality in line is rest operator and spread operator. Both has got the same syntax, but the functionality differs. Spread operator expands iterables into individual elements, whereas the rest operator puts the rest of the user supplied values into an array. Let's see it in action. Let's create an object called person having two properties, name and age. Let's create one more object called address, and let's pull out all the properties in person into the address using the 3 dots. Now this syntax is called spread operator, which basically spreads all the properties from the person into address, and I'm adding 2 more properties on the address object. If I want, I can go ahead and overwrite the property from the person as well. So if I do name colon Bob, so it essentially pulls out the name and age and puts it here, and later I overwrite the value to a different one. So if I console we could see that the address has got all the property mentioned here, all the property in the person, but the name is overwritten. So that is what spread operator is all about. It virtually spreads the property of an object into another one. Now the same can be done for arrays also. Let's create a string array. Let's call it colors and have an array of colors. Let's have a variable called rainbow, which is an array. And what I'm doing here is similar to what we done in the previous example. Let's pull out all the individual values from the colors array and then let's add the rest of the colors. So if I console rainbow now, we have all 7 colors. Out of that, the rainbow already had 4 colors here, and the rest of the 3 colors has been pulled out from the colors array and added to the start of the new array. So this can be given at front or this can be given towards the end, whichever way we want. So that is spread operators used on arrays. To see the rest operator in action, let's start by having a function. This time, let's invoke the function with some arguments. So if we have 1, 2, 3, 4, 5 arguments here, we need 5 parameters for this function to catch all these individual values. But instead of that, what I'm doing is I have one parameter called winner, and the rest of the arguments which we passed will be passed into the others parameter as an array. So if we console both, what we could see is the winner is Ben, which is this one, and the rest of the arguments which we passed was collected as an array. So this will give us an array of whatever we have passed here. We can make use of that functionality and we can call any array related methods on top of this one. So if I console.log this, all I did was I know that what I'm getting here is an array. So I'm just mapping over the array, taking the individual items and calling to uppercase on that. So I have all the individual items in uppercase. So that is rest operator. The next feature we are going to discuss is prototypes and classes. A class is nothing but a wrapper over a function prototype. But we need to understand prototypes and inheritance first. By design, JavaScript is object oriented. So there is no concept of classes to begin with, but only objects. And that's why we call it OOP or object oriented programming. This made programmers from other classical languages like C# or Java a bit hesitant to adopt JavaScript purely because of the hassles related to learning and understanding prototype and prototype chains. Wrapping the head around this concept wasn't easy either. Let me introduce the concept of prototype through simple small examples. And my aim here is to explain a concept with the least amount of code. So let's start by having two empty functions. So we have a function called user details. So this is a traditional function. And let's have an arrow function. Let's console and see what we have. So if we console, there is nothing new here. But if I put a dot, what happens? So just like an object have properties, functions also have properties. So one of the property is prototype. So let's see what the prototype is. So if I save, we see that for the traditional function, we have an object as the prototype. And for arrow functions, we don't have any. So that's point number one. All traditional functions has a special property called prototype, and the exception is arrow functions. They don't have a prototype property. We see that the prototype is an object with a constructor property within. But the question is, what is this weird object and why do we need it? To understand that, let's start from scratch. So since I said JavaScript is object oriented, let's start from that point. Let's start by creating an object. So I have an object called user. Since an object can have properties and methods, let's add two properties and a method. So this object has got two properties and a method called getDetails, which just prints the name and the age. Let's have one more object. So I created user2. This also have a name and an age and a getDetails method. Let's invoke the getDetails method on both objects and see what we get. So we get hello, the name and the string which contains the age. Similar for the next one as well. The problem here is if I console the user, what do we have? So we know that this user object has got a property as well as a method. But the problem here is the getDetails method is pretty much the same irrespective of whatever user instance we have. So virtually every single object instance is carrying its own copy of getDetails, which is an overhead. Methods are meant to be shared across instances. They don't need to be attached to every object instance. So we need to figure out a way to pull out the methods from the object instance and share them across. We will do that step by step, but before that, let's refactor the existing code. Rather than objects lying around the code, let's create a function. So I'm creating a function called createUser. We know that there are two properties, name and age. So let's accept two parameters, name and age. Let's create a user and straight away return the user. Once that is done, let's attach the name and age properties to the user object. We know that there is a method called getDetails. So let's attach the getDetails method onto the user object. And now using the function, I'm creating an instance of the user. So I call createUser, passed in the name and the age. And this, whatever this returns is being held on this variable. So if I call u1.getDetails and u2.getDetails, right now we have two individual instances of this user. So nothing has changed as of now, but we have just refactored the existing code so that we use a function to stamp out individual instances of the object. Now let me clean up this a bit. So let's take this piece out. Let's take these two pieces out. We are back to the same place, but instead of having an object, we use a function to stamp out individual instances of this object. So if we console u1 and u2, we see that the objects still have the property as well as method on the instance. So apart from the refactoring, nothing has changed. We need to figure out a way to take the method out of this function and share them across all the users' individual instance. For that, let's create an object. You can name it whatever you want, but here I'm naming it as shared. So into the shared object, I take the method, cut it from here, and I'm pasting it here. And since objects are key value pairs, let me give it as a key value pair. Now to connect this shared object with the function, I can use object.create and pass in the shared object. So this one line, what this does is object.create helps us to have failed lookups. So delegating to failed lookups. So essentially what that means is if you do not find a particular property or method within this function, don't throw the error. Instead, just go and search the shared object mentioned here as well. So that this is something like our garage or storeroom where we put our common stuff. If you don't find it within the house, just go and search the garage as well. So similar to that, if we don't find something within this function, just go and search the shared object as well. This shared object is affectionately called as prototype in JavaScript. If we notice, we have the shared object here, and on line 17 and line 20 we are calling get details. We are still able to get the get details method invoked from the shared object, and we still get hello Ben, you are 22, and hello Jane, you are 24 because of this prototype link. So is it better now? Yes. Can it be made better? Of course, yes. So let's identify the pain points we have currently. So let me take a note here. So these are my pain points. Creating a shared object explicitly, that is step number 1. Linking the same using object.create, step number 2. Returning the user, this is step number 3. So these 3 points are the pain points we have currently. If I am asked the same question in an interview, probably I might miss out on one of these steps. So how can we make this code a bit more better? That's where we can make use of something called new in JavaScript. Just as a matter of keeping the best practices, a constructor function always starts with a capital letter. So instead of small c, let's switch that to a capital C. This is not a must, but this is just like a best practice, so that a fellow developer just by seeing the code knows that this is not just a normal function. This is a constructor function which will be newer later. Let's address these pain points one by one. So at the start of the video, I told if I put a function dot, we can see that there is something called a prototype, which is an object. So that is an indication by JavaScript to put all the common stuffs in the prototype object. So rather than we creating a shared object explicitly and linking with object.create, we don't need to do this. So let's take this piece out. Let's take the return out. Let's cut the get details from here. Let's remove the const shared object, and let's go to create user dot prototype. On the prototype, I'm attaching our common function. So prototype dot get details equal to our function. So that is step number 1. Now, if we use the new keyword in JavaScript, this helps us with the other 2 steps of linking the same using object.create and returning the user. These 2 steps are done behind the scenes for us the moment we use new create user of parameters. And since this is a constructor function, we no longer have the user. Instead, we use this dot name and this dot age. So if everything is done right, the console should show us that we have the console messages as well as the objects created. So the instance no longer have the method, but still through the prototype, we are still able to call the getDetails method and have the console done here. If you want to see the shared object, there is one shortcut. So on U1, there is a built-in property called underscore proto underscore or double underscore proto double underscore. So if we use that on both user instance, we see that we get an object with 2 properties. One, the constructor function, and second, the get details property. So we have already seen that the prototype object had a constructor property by default, and since we have attached the get details method to the prototype property, now this is made accessible here. To confirm the fact that we are sharing the same getDetails method across different user instances, we can check u1.proto triple equals to u2.proto. If this returns true, that indeed means that the same method is getting shared across different user instances. So if we save and run, this returned true. Thereby, we can confirm the fact that the same method is being shared across user instances. Let me ask you one small question. So if I console, say u1.age.toString and save, we get 22. But where is this toString coming from, and why is that the browser didn't throw an error? Because neither in create user nor in the prototype we have a method called toString. We have something called getDetails, but that is not toString. But still this is printing and the console is not throwing an error. Why? Now that is because of the prototype chain. So if you take a look at console.log of u1, the user, let's dig into this user. So let's go to the create user. You can see something called prototype. So essentially this is our shared object. So within the shared object, we can certainly see the getDetails which we have here. So this is our prototype. So if we don't find it in create user, naturally it will fall back to our prototype. So it will go and check our prototype shared object to see if there is something called toString. If it finds here, it will use it from here, or else this will go one level up to its prototype. So it will go and search its prototype to see if there is something called a toString. And since there was a method called toString, it used the toString from here. If it couldn't find such a method, then it would have thrown an error. So this is the prototype chain. If something is not found, first it goes to its prototype. If it is not found there, it will go to its prototype. So it will go n level up till the root object. So once it hits the root object's prototype, if it finds there, well and good, else it will throw the error. If this feels overwhelming, I totally understand it. Please don't stress out. It took me a lot of attempts to wrap my head over this concept initially. So if you find it tough, please go through the lecture a few times, write the code and track it down yourself so that it sticks in your memory. Keeping everything we have discussed in the past 15 minutes, let's practice what we have learned and try implementing inheritance with ES5 so that we appreciate the value of ES6 classes even more. Let's define a constructor function called person, which accepts name and age as the two parameters. And since this is a constructor function, we can write this dot name equal to name and this dot age equal to age. Now let's have a prototype method called greet. Let's say greet returns hello name, how are you? So let's new up the constructor function, pass in the parameters, and let's see if we call p1.greet, what do we have in the console? So we have hello name, how are you? So we are invoking the greet method in prototype as we expect. Let's create one more constructor function called employee. So employee is still a person. So employee has a name, age and a designation, out of which name and age is common to person. Since this is a constructor function, let's do this dot name equal to name, this dot age equal to age, and this dot designation equal to designation. So once that's done, let's create a method and attach it to the prototype called details. So the details method says name is a designation. So if we new up the employee constructor function, pass in the arguments And if we do even.details, what do we have here? We have Ben is a developer. So the details method in prototype is also invoked as expected. But what we want here is to inherit person, because employee is still a person. Before implementing inheritance, let's clear the clutter. Let's remove the unnecessary console log. I don't need this instantiation here either. So let's remove both of them. For me, I always remind myself that inheritance in ES5 is a 3-step process. So let me make a note of that here. Step number 1 would be fixing the variable reference. Step number 2 would be fixing the shared object reference. Step number 3 would be fix prototype constructor. So even if I don't remember everything, I remember that there are at least 3 steps to be done to implement inheritance using ES5. So let's go step by step. I know that the name and age should come from the person because we are inheriting from the person. So as a step 1, let's do person dot call and pass in the object to be used as the current object, which is this. Pass in the name and age. So this fixes our point number 1. Now to fix point number 2, the shared object reference, let's do one thing. So as of now, our employee constructor functions prototype only have the details. When we inherit from person, we know we need to inherit the greet method as well. And the greet method lies within the person's prototype. So we need to get this greet method also from the person's prototype and add it to the employee. Then only the employee instance will have access to both details as well as greet. To do that, let's do employee dot prototype equal to object dot create of person dot prototype. So after this line, we essentially said whatever that lies in person dot prototype, we need to be part of this employee dot prototype as well. So we are just pointing it to person's prototype here. So after this line, we make sure that we have access to the greet method of the person's prototype along with the details. Now let's test our progress. So console.log of even dot, if it worked well, we should be able to call greet on employee, and it did work because even.greet returned hello Ben, how are you, and the greet comes from the person's prototype. So till this point our inheritance is working fine. So is that it? No, because there is one more point that we need to consider. So we fix the shared object reference. Now this is a tricky one. To find out, let's do one thing. So console.log of even instance of employee. So all I am checking is that even is an instance of employee, which returns true. So that's obvious because even is an employee instance. But if you do console.log of employee.prototype.constructor, here lies the problem, because employee's prototype constructor is hanging around the person. Instead, we want that to be of employees. So to fix that, we need to do employee.prototype.constructor equal to employee. So once this is done, we reset the prototype constructor property back to employee. So only after having this line, we make sure that the constructor points right, which can be tricky at times. We implemented inheritance in ES5, but I must admit it was a lot of cognitive load, a lot of effort to make sure that we join all the dots one after the other. Chances are there are areas where we can miss out and go wrong. That's where classes help us a lot in handling a lot of these things behind the scenes and giving us a much simpler interface to implement inheritance. Now let's do the same thing using classes. To compare both approaches, let me create a dummy file called dummy.js. Copy paste the entire ES5 solution into this one. Put it side by side so that looking at the implementation of ES5, we can do the ES6 version of it. Let's start by declaring a class called person. And we know that the constructor function accepts the name and age, and since this is a class, classes have constructors which accepts the same properties or the parameters name and age. So the constructor accepts name and age as the parameter, and we can call this .name and this .age. And since we know that the person's prototype has got a greet method, let's have the same greet method taken from here, the same return value as well. Let's have one more class called employee. And now we need to inherit from person. And for that, in ES6, we use a keyword called extends. So I'm saying class employee extends person. And since this is a class, it has got a constructor, and the constructor takes in 3 parameters. So name, age and designation. So let the constructor take in name, age and designation here. Whenever we implement inheritance, it's important to call super and pass in the parameters it required for the parent class constructor. So here we call super, pass in name and age so that it calls the parent class person's constructor. So it instantiates this one when we trigger super of name and age. And since we have designation here as well, let's do this dot designation equal to designation. And since we know that the employee prototype has got a details method, let's have the same details method here. And if everything goes fine, let's instantiate the employee class, pass in the arguments it requires, and let's console and see what do we have. So let's bring back the browser. Let's console the instance, and we could see that the employee instance has got name, age and designation. Let's try calling the details method. So even.details. This gives us the name is a designation, which is Ben is a developer. So the details method is working. And to test inheritance, let's try calling the greet method. Let's call even.greet. So we have hello with the name and the message, which is nothing but the greet method. And to track our prototype chain, let's have console.log of even.__proto__. So we are taking a peek at the shared object. So the shared object have constructor and details, which is this one, and its prototype has got constructor as well as greet, which is the parent class method. So that is working fine as well. So this is the ES6 version of inheritance. The next feature in list is generators. Generators is a new way to work with iterators and functions. With generators, we can enter, exit and re-enter into the same function multiple times. Generators, although it looks like a function, it behaves like an iterator. and generators can produce a sequence of results instead of one single value. And let's see generators in action. Let's start with a normal function. So we have a function, I'm just calling it test, and I'm having a bunch of console logs. But I cannot say, okay, after 2 console logs, please don't proceed. So just pause after line 3. Let's resume later. The moment I invoke the function, everything gets run together. So we have 1, 2, the message, and then 3. If we need to break the execution of this function, we can either have a return or a throw. Let's have one more function. This time I'm naming it test generators. And to make a normal function a generator function, let's put a star at the end of the function keyword. And now let's bring back our consoles. I'm saying console 1 and 2, so both messages. After this, I wanted a pause. So to let the JavaScript compiler know to pause the function execution in between, let's have a yield. Let's have the keyword yield along with an optional message. So the execution pauses after printing these 2 console messages. Let's have the next message after that and have the next yield so that the execution pauses for the second time after printing this message. And let's have the final console after that. Let's invoke the function, assign it to a variable, console the value, and then see what happens. So in the console, we can see that there is a test generator with the value of suspended. So this basically means the generator as of now is on a suspended status. So to trigger the function execution, we need to call the next method on this. So if we can do gen.next, assign it to a variable and then console the variable, we can see that the function execution was triggered. It printed 1, 2, and the function execution paused at line 12 at this yield. So since we have an optional message called this message was returned along with a property called done false. Now done false basically means we still can call the next to proceed with the execution. So if we call gen.next again and let's console the value, now the execution resumed from this point. It printed this line and then again paused at line 14. And we know that we have this value paused at point 2. So the function is paused at this line with done false, which means that there is still code to be executed. So let's call gen.next again and then console the value. Now we see that the value is undefined and done is true, which means that there is no more thing to iterate and the function has completed its execution. Let's see an example where we iterate over an object using a generator function and something called an iterator function. To begin, let's define an object called team1 with 4 properties: developer, tester, designer, and manager. Let's have one more object called team2 with the same properties but with a few extra properties as well. So the team2 also have developer, tester, designer, manager, but it also has 3 other extra properties. Now let's build a bigger object called bigger team by clubbing team1 and team2. Let's start by writing an iterator function. So the iterator functions are defined similar to our generator functions. I'm saying function with a star, the name we want, that can be anything. Since I know that I'm going to iterate team1, so I'm giving the name as team1 iterator. It accepts an object which is a team, and from the object I'm saying please yield team.developer, team.tester, and team.designer. So all I am saying here is when the iterator loops over the team1. I don't want the full properties, but please pick and choose the first 3 properties from team1 using team1 iterator. Similarly, let's create one more iterator for team2. So function with the star, the name of the iterator, which is team2 iterator. We'll pass in an object, and from the object, please yield team.developer and team.manager. So once that's done, let's create a generator function called function star team name generator. I'll pass in a team, and I'm saying yield with a star. Notice that there is a star after the yield keyword. So that again means you will be iterating through an iterator function. So yield star team1 iterator. I pass the bigger team, and from the bigger team, please choose team.team1. Yield team2 iterator and iterate through the team2 object. Let's create an array and let's loop over using for of, and I'm saying please loop over the team name generator by passing the bigger team object, and please push the individual elements into the array. So if we console.log the array, we have Ben, Tina, Dave, Chris and Peter. So from team1 we have developer, tester and designer. So Ben, Tina and Dave are the entries from team1, and from team2 we picked the developer and manager. So here I'm saying Chris and Peter. So that's what we have here. So this is a small example for iterating through an object using generator functions and iterator functions. The same example can be further simplified using something called symbols. So symbol is an ES6 primitive, and the MDN documentation says symbol.iterator. It specifies the default iterator for an object. So if we use this within an object, we can specify what to loop over and return when we actually loop through it. So going back to our previous example, for team1 iterator, we wanted to return developer, tester and designer. So let's go to the object, and I'm saying symbol.iterator and the generator function. Please go ahead and yield this.developer, tester and designer, which is exactly the same as what we have yielded here. So we no longer need a separate iterator function. This is being handled within the object itself, and pretty much the same approach for the second object. So let's have the symbol.iterator following the generator function pattern, and let's yield developer and manager, which is exactly what we have here. So we no longer need the separate iterator functions, and we can further simplify the generator function by omitting the iterator function names, and this should give us the same output, which it did. So this is a small simplification if we go ahead and use symbols. The next feature in line is symbols. Symbols is the new primitive types introduced in ES6. They are just a piece of memory holding some data, with the guarantee that each symbol points to a different memory location, and the value returned by the symbol constructor will be unique and immutable. They are often used to add unique property keys to an object, and they enables a form of weak encapsulation. There is a lot of jargons here, so let's take a small example and see how it works. Let's create a primitive type. So let's have A and B pointing to the same value. If we compare A with B using triple equals, we see that we get true. So if we use symbols, which is also a primitive types, let's have a symbol called symbol of 1 assigned against a variable. Let's have one more variable called 2. This time the same symbol assigned against another variable 2. And if we compare 1 with 2, we see that what we get is false, because symbols return unique identifiers and symbol is a piece of unique memory location. So no two memory location would be equal. Let's create a symbol called username. Let's create another symbol called user age. And let me show you encapsulation using symbols. So let's create a class called person. The class has got a constructor which accepts two parameters, name and age. But within the constructor, I'm saying this of username equal to name and this of user age equal to age. So here, instead of a regular variable, I'm replacing that with a symbol. So if I instantiate the person class by passing the arguments, let's console person and see what it is. So here what we get is not just a regular object, what we get is a symbol. So this is more like a lock and a key thing. What we get is the lock. To unlock it, we need the right key. So until and unless we know the symbol key used, we cannot unlock the value out of it. So if we write something like this, person of the symbol name, then we'll get the right value. Similarly, if I can write person of user age, we'll get the value for it. But the value will be accessible only if you know the symbol name. So we have encapsulated the actual value using the symbol keys. So that's encapsulation using symbols. The next feature in line is promises. Now promises help us implement asynchronous programming. Promises also helps us to avoid callback patterns. End of the day, a promise is just an object that represents a task that may or may not be completed at a future point in time. Let's see the problems with the callback patterns and let's see how promises can help us write better code when it comes to handling asynchronicity. The problem with callbacks is that they create deeply nested code bases that is tough to read, maintain, test and scale. So this is an example of something called callback hell, where we have a bunch of code and its logic where there is something asynchronous happening, and within the code, once something has happened, it triggers further logic. Now this code will grow even deeper if there is more logic. So it creates kind of a nested hell hierarchy, which is extremely tough to read, understand, test, maintain and scale. The bigger problem lies with the inversion of control. So let's see what the problem is. So imagine this is your project's code base and some part of the code base depends upon a third-party NPM package. So imagine that we are importing a method from your favorite NPM package and assume that this is that particular function. So all we do is we invoke the method, pass in the required arguments and expects that it works well. So in this case, if we save, we get 50 because we passed the amount, the quantity and the callback function. So till this point, things are good. But what if the third-party library's code failed and they forgot to have the callback function implemented? There is nothing wrong from our application side, but still we won't get a result because we purely depend upon the third-party library to provide us with the callback function and its response, which is an inversion of control. This makes our application unpredictable. From our application's perspective, we should be able to track whether the current request is still in progress, whether it's successful or whether it's failed. That's what promises help us with. Let's have a function that does something asynchronous and use promises to handle that asynchronicity. So let's have a function called fetch API. Let's invoke the function, and within the function, let's create a promise. So a promise is created using const, a name that can be anything. I use promise equal to new promise of, and to the promise we pass in a function. So this function takes in two parameters. One, the resolve. Second, the reject. So whatever asynchronous thing which we are doing within, if it is successful, we can call the resolve function and pass in the data. Or if it is a failure, we can call the reject method and pass in the error. Let's use something called fetch. So fetch is a browser interface which allows us to make HTTP request. So to the fetch function, I'm passing the URL. So let's pass the URL. Since fetch is a promise, so if you hover, we can see that the fetch returns promise. So let's change the promise using .then. So I'm saying once you have a response, pull out the JSON from the response and return it. Once that is there, that's also a promise. So once that's done, then once you get the data, call the resolve method and pass in the data. Or if there is an error, catch the error, call the reject method and pass in the error object. Let's console the status of the promise and see what that is. So let's console the promise. And we could see that the promise is currently in the pending status. So once the HTTP request is resolved, what we get is the data which is passed to the resolve callback function. And if the resolve is invoked, we could use promise.then to capture the value passed into the resolve callback function. For whatever reason, if this request fails, then the error that would be passed into the reject callback, and that can be caught using promise.catch. So let's do promise.then. So if the request was successful, the data passed from here would be made available here. So let's console the promise and the data. Also, let's add a catch block so that for whatever reason, if there was an error, that would be caught here as well. So if we run, we could see that initially the promise was pending. After some time, the promise was fulfilled. So the status turned from pending to fulfilled, and we have the response made available within the then block. If we fail the API, the reject was triggered by passing the error which was caught in the catch block, and the console.log something.failed was shown in the console as well. There is something called promise.all which can come in quite handy if we need to wait for multiple promises to be resolved or rejected before moving forward. Let's see that in a small example. Let's have two fetch API calls, one for to-dos and one for post. So we know that fetch returns promises. So to-dos and post variables are currently promises. We could use promise.all which accepts an array, and let's pass in the to-dos and post into the array. And then we could use .then and catch the responses provided both requests were successful, or we could use catch to catch the error if one or both of the requests failed. Let's save and see what happens. So if we save, we could see that we have the responses for to-dos and post. So the first one corresponds to the response of to-dos and the second one corresponds to the post. If we fail one of the APIs, we could see that the promise failed and the error was caught in the catch block. So that's promises in a nutshell for you. With that, we come to the end of this ES6 series. I hope this was helpful in understanding the ES6 features and functionalities and some of the hard topics like prototype and inheritance and prototype chains, and also new features like generators and symbols. Do let me know your thoughts in the comment sections below. I'll see you all in another video. Thank you and bye-bye.